guys, welcome back to my channel. Hope all you are fine. Today's topic is CSWIP 3.1 Welding Inspector. This is the part 7. You know the part 1 to part 6 all videos are uploaded with their explanation. So you people are enjoyed with this video. So before proceeding this video, I want to say those people want to get more videos on this channel regarding QA/QC or regarding any type of CC 3.1 and AWS question or NDT question. Just give a comment to me that I want that type of video so that I can make that video. In that basis, please subscribe my channel. Then when I uploaded my video, then definitely you can get it very fast. So thanks a lot. So let's start the video. So here also good questions with their explanation are there. Main things are there. You know the questions, you know the answer, but where the answer is coming from. So you need to know that. So that the explanation is very important in any type of questions. So let's start. The first question is which of the following imperfection types is not usually associated with TIG welding? So they are telling some defects are there. The defects generated by any welding generated in welding joint, so that is not in related with the TIG welding. So let's see. The option is A. First option is tungsten inclusion. B is lack of root fusion. C is cutter pipes. D is spatter. So fourth option is here. So you have to choose the right one. So you have to know first tungsten inclusion. It is associated with TIG welding or not? Means which is not associated with TIG welding. Definitely tungsten inclusion is associated with TIG welding. Lack of root fusion also associated with the TIG welding, and cutter pipe also associated with the TIG welding, but spatter is not associated with the TIG welding. You cannot see in the tungsten inert gas welding in the spatter. Most of welding defects with TIG are caused by a lack of welder skill. So you have to know very carefully. Most welding defects, whatever welding defects in TIG welding, it's caused by a lack of welder skill. Mean welder skill is not there, maybe the approved welder is not there. Or incorrect setting of the equipment, means there is a setting of current voltage, you can say the torch manipulation, welding speed or gas flow rate. It's not setting properly as per the WPS. That's why the result is coming very bad, means the defect is coming. So you can say the tungsten inclusion, that is coming for low skill or wrong vertex angle. If the vertex angle is very wrong and the low skill operator is there, definitely the tungsten inclusion can be generated. Surface porosity, loss of gas seal mainly on side. So you can say that is not properly gas shielding. What is the flow rate should be there, that flow rate is not correct, that is coming. Why this is coming? The surface porosity. Cutter pipes, bad weld finish technique, that is slope out. So slope out is not correct, that is coming the when the welder is starting the any welding. After that, when they are finished, that the one rod electrode rod is finished, that time, that is bad weld finish technique called the cutter pipes. Oxidation of SS weld bead or root by poor gas cover. So if there is a poor gas cover is there, then definitely oxidation will be generated in SS weld bead. And the root concavity, excess purge pressure in pipe. If there is the excess purge pressure in the pipe, then root concavity will be generated. Lack of penetration, fusion, widely on root runs. So lack of root penetration and root fusion you can see in this TIG welding. So what you cannot see, actually spatter you cannot see. So the correct answer will be the answer D. So you understand this question. So let's go the second question. Which which polarity is normally used to GTAW welding of aluminium? This is very important question, and this is very important question every time it comes in CC 3.1 question. First option is AC, B is DC electrode negative, option C is DC electrode positive, and option D is it would make little difference which gas used. So definitely there is some explanation is here in tungsten electrode. So there is two types of tungsten electrode is there. One is thoriated, another is zirconiated. So thoriated is used for steel and most metal, and zirconiated, that is for AC, aluminium alloys and magnesium. So the polarity used in zirconiated is AC, means for aluminium alloys. So definitely the answer will be option A will be the correct answer. You see the AC. DC electrode and DC electrode negative, this is for steel and steel alloy. And option D, it will not be the any answer, it will be the wrong answer. It would make little difference which was used. So it will not be the correct one. So correct one will be the option A is the correct one. So let's go the third question. Which is a typical arc voltage setting when welding with the TIG? So what is the one typical setting should be there when you are welding with the TIG GTAW process? So you know very well, you should know there is four option. One is 18 to 20 volt, B is 24 to 26 volt, C is 10 to 12 volt, and D is 70 to 90 volt. Now, you understand here the arc characteristic for TIG welding is a constant current. So this is the constant current process. In TIG welding is the constant current process. You see here, so many processes here, MMA, you see here MMA, then TIG, then MIG, then MAG, CSW, SWIP and electroslag. This is the process of welding process. So which welding process, which electrical characteristic is mentioned here? MMA is the constant current. TIG is the constant current. That is also called the drooping. MIG is the constant voltage, MIG or MAG. MAG, FCAW is the constant voltage characteristic. So every process have the different characteristic. Now you should know the constant current is TIG. Now we'll go for constant current, which voltage will be there. So there is a curve is there on graph. I'll show you now. The constant current characteristic is one side is volt, another side is the welding current ampere. So this is the welding arc. You see here, this is welding arc. This is power supply. This is the OCB. OCB is 75. From here it is 75. Now the power supply is coming here like this, and this is your welding arc. It is generating. It is actually 25 and 35 in between. It is vary. So the mention here you can see the A, B, C, D, four option is there. So you have to go the B. Option B is the correct answer. 24 to 26 voltage. This is the typical voltage of TIG process. So answer B is the correct one. Now the question 4, in TIG welding hydrogen is added to argon for the welding of which type of steel? In TIG welding hydrogen is added to argon, means in TIG welding you see the hydrogen, it is added to argon for the welding of which type of steel? So you see here, first is carbon steel, second is copper, C is carbon manganese steel, and option D is the austenitic stainless steel. You should know very well there is a argon gas, but there is some hydrogen is added with the argon for which type of welding and which type of steel. In TIG welding, actually, which type of steel? The question is which type of steel. Now, there is explanation is there. You see the gas type and gas flow rate. Generally, two types of gases are used in TIG welding. You should know the two types of gases here. One is the argon, another is helium. Then two gas we are used in TIG welding. So nitrogen may be considered for welding copper and hydrogen may be added for the welding of austenitic stainless steel. when you are doing the welding of austenitic stainless steel, that time copper and hydrogen, either copper, either hydrogen is added with the argon. So that is the important you should know when you are doing the austenitic stainless steel welding. So hydrogen or copper with added with the argon. The gas flow rate is also important. You see here the shielding gases for GTAW welding. So this answer will be, you understand now, austenitic stainless steel hydrogen is added with the argon. So the correct answer will be the option D is the correct answer. D is the correct answer, austenitic stainless steel. Now you can see here the shielding gases for TIG GTAW welding. The normal gas for TIG welding is argon. Everyone knows the normal gas for TIG welding is argon. Helium can be added to increase the penetration. Why we are using the helium? Because of the increase the penetration and fluidity of the weld pool. Means the penetration increase and the fluidity of the weld pool. That's why helium is added with the argon. Argon or argon helium mixture can be used for welding all grades. Means if we are using argon or argon helium grades, this mixture it will be used in all types of grade we can use. In some cases nitrogen or hydrogen can be added in order to achieve special properties. Sometimes we are using nitrogen or hydrogen. Why we are using? Because of the, maybe it is client requirement to achieve the some special properties. For instance, the addition of hydrogen gives a similar but much stronger. Means, for instance, if you are giving the argon, but instead you are giving the hydrogen, it gives a similar strength but much stronger effect as adding helium. However, hydrogen addition should not be used for welding martensite. Hydrogen we cannot use when you are welding martensite, ferrite, and duplex grade. So you understand the shielding gases used in TIG welding. So the answer will be 4D. Question number 5. Which tungsten electrode is usually used to weld aluminium? So I already explained this one. Zirconiated, B is thoriated, C is large diameter, D is pointed electrode. So question is, which tungsten electrode is usually used to weld aluminium? Definitely it should be zirconiated. You see here mentioned zirconiated aluminium and aluminium alloys magnesium. So correct answer will be the option A. Question 6. What may be a reason for using nitrogen gas in TIG welding? Why we are using nitrogen gas in TIG welding? Because of to stabilize the arc when welding carbon steel, it can be used to weld copper. The gas used is always the choice of the welder. It is the very best gas to the weld nickel salute. The first one is to stabilize the arc when welding the carbon steel. No, nitrogen gas we are not using for stabilizing. Second is it can be used to weld copper. It could be a answer. The gas used is always the choice of the welder. No, definitely we cannot choose as per the welder. It should be as per WPS or as per specification. It is the very best gas to weld nickel. Not for very best or cheap. We have to use as per the WPS. Now the option B will be the correct one. Let's see. Gas type and flow rate. Generally, two types of gases are used in TIG welding. One is argon, another is helium. So nitrogen may be considered for welding copper. So you understand? Nitrogen you are using to weld copper. It is mentioned here may be considered for welding copper, and hydrogen may be added in the welding of austenite steel. So nitrogen may be considered in welding copper, and hydrogen may be added of the welding of austenite steel. So these two things is different. When nitrogen is added, it is welding for copper. When hydrogen is added with the argon, then you are welding for austenite stainless steel. So the correct answer will be the 6B. Question number 7. What is the mode of metal transfer for the TIG welding process? So you know the metal transfer, how many types of metal transfer is there. So for TIG welding, which one the metal transfer? It is for TIG welding. One is phase transfer, second is globular transfer, C is deep transfer, D is none of the above. Now you have to check here the explanation. The filler metal is added directly to the weld puddle. So in TIG welding, what happened? The filler metal is added directly to the weld puddle, not transferred across the arc, but is melted by it. Second is the difference between an electrode and a rod is that an electrode carries welding current and the metal transfer across the arc. Means electrode carries the welding current and the metal transfer across the arc. But a filler rod, what will happen? The filler rod is added directly to the weld puddle without electricity running through it. So electrode and the filler rod, it's the different criteria. So answer will be D, none of the above. So which mode of metal transfer of TIG welding process? Not spray, not globular, not deep. Question 8. When MIG or MAG welding wire feed speed is proportional to table speed, B welding current, C arc length, D inductance. So which one is the right answer? When MIG or MAG welding wire feed speed is proportional to wire feed speed, always if it is increased, definitely it will increase the current. So welding current is the correct one. Travel speed, no. The wire speed is proportional to the arc length, not inductance, not travel speed. It should be the welding current. Answer B. Question 9. In the MAG welding process, metal active gas welding process, which gas type gives good penetration but an unstable arc and high level of spatter? So if you see the MAG welding process, which gas gives good penetration, means which gas gives good penetration but an unstable arc and high level of spatter, it is there. Pure carbon dioxide, B is pure argon, C is argon plus 5 to 20% carbon dioxide, D is argon plus 1 to 2% oxygen or carbon dioxide. So which one is the correct one? So we'll go now on explanation. Shielding gases. The gases used in MIG or MAG welding, definitely 100% CO2 or argon plus CO2 mixture. When you are using the MAG welding or MIG welding, we are using 100% CO2 or argon plus CO2 mixtures. Now 100% CO2 cannot sustain true spray transfer but gives very good penetration. The arc is unstable, which produces a lot of spatter and a coarse weld profile. So you understand now here what is meaning? In spray transfer, you see the good penetration is there, but arc is unstable, but lot of spatter is and coarse weld profile. So you can understand here which gas type gives good penetration but an unstable arc and high level of spatter. Pure carbon dioxide, pure argon plus 5 to 20%. Pure carbon dioxide means 100% carbon dioxide. So the correct answer will be the answer A. In argon plus CO2, you can see here the explanation. Argon can sustain spray transfer also above 24 volt and gives a very stable arc, not unstable. But it is mentioned here, it is given the unstable arc. So the answer A is the correct answer, correct option. Now, question number 10, the output characteristic of typical mag set is. The output characteristic of typical mag set. So what is the output characteristic of typical mag set? Is the constant voltage or constant current or dropping or pulsing? So definitely the same I have explained in the previous question. You can see here the mag. Mag means is here. It is the constant voltage characteristic. So correct answer will be the constant voltage. Answer A means option A is the correct answer. I think you understand solve this question with their explanation. Thanks a lot. Please like, share and subscribe my channel to get the regular video. I think it is the series 7, so I will continue this series whatever I have the latest question here. Thanks a lot. Take care.